Welcome everyone, my name is Krzysztof Topolski, I represent Warsaw University of Technology in Poland, and now I have a great pleasure to present the results of my research. The topic of this research is homogeneity of titanium manufactured by solid-state chips recycling. At the beginning, I would like to introduce the subject of this work and explain the purpose of this work. This work refers to the subject of metallic chips recycling. The material recycled was high-purity titanium. It has titanium with purity of 99.99%. In this work, chips after milling were processed. They were subject to a three-step procedure with the aim to transform them into a solid material. The purpose of this work was to determine the homogeneity of the final material obtained. The final product had a diameter of 8 mm and length about 700 mm. Such a material can be considered to be a relatively bulk and volumetric material. In the case of such a new and relatively volumetric product, the research of homogeneity was fully reasonable. Now, please, let's look at the section number 3, entitled Procedure of Chip Processing. In this section, the chip recycling procedure was presented. This processing was carried out in the solid state, it means without the remelting phenomena. At the beginning, the chips were preliminarily consolidated by upsetting method. By this way, the agglomerate called briquette was obtained. In the next step, the briquette was subjected to the heating and annealing. Next, in the final step, the briquette was extruded. In this stage, in order to consolidate the chips into monolithic material, the unconventional plastic working method was used. This method was a direct extrusion with a rotating die. The processing method employed resulted in the formation of a bulk, solid and consolidated product in the form of rod with a diameter of 8 mm and length of 700 mm. The research methodology is presented in the section number 4, entitled Methods of Investigation. In this work, to evaluate the homogeneity of the manufactured rod, the microstructure and mechanical properties were investigated. The method of investigation and obtaining the samples are presented in the figure 4. The microstructure was analyzed using light microscopy. The mechanical properties were analyzed by the hardness measurements, microhardness measurements, compression test, and tensile test. Most of the tests were conducted using two different samples taken from the two different areas of the rod. This approach made it possible to examine the homogeneity on the length of the product. And now, please, let's move to the results of investigation. The results of investigation are presented in section number 5. In the section number 5.1, the microhardness measurements were presented. As it can be seen in the table, when analyzing the transverse section, the microhardness distribution and its average value along two perpendicular axes diameters were shown. It was found that the results were similar. These data indicate a high homogeneity and isotropy of mechanical properties of the recycled material. Comparing both sections with each other, it was observed that the results were similar too. Therefore, this material can be considered as homogeneous within the entire tested volume. Now, let's look at the section number 5.2. This section refers to the hardness measurements. The samples were cut off from different areas of the rod. Despite this fact, the hardness values was obtained were very similar. During the hardness measurements, indentation tracks were formed. Based on the microscopic observation, it was found that the both tracks were symmetrical. Therefore, it was shown that the rod exhibited homogeneity of the mechanical properties. It means isotropy of the mechanical properties. So, the results of the hardness measurements indicate that the rod is homogeneous along its length. In the section number 5.3, the homogeneity of the structure was presented. The results of microstructure investigation are visible in figures 6a and 6b. The recycled titanium exhibited a very homogeneous microstructure with equiaxed similar grains. Over the entire tested surface of each section, there were grains of very similar size and shape, what was confirmed by the small values of the SD and CV coefficients. There were no microstructural differences in different regions of the sample. Moreover, it was found that the microstructure was the same in both sections. Because of the longitudinal section, no effect of texture on elongated grains was observed. This effect often occurs in the products such as the rod. Now, I would like to show the results of compression test. This is section number 5.4. In the figure 7, the strain-stress curves obtained from the compression test are visible. The results of this investigation show that two different samples taken from different areas of the rod exhibited the same plasticity and strength. The two compression curves are coincident and they overlap each other closely. Moreover, the calculated values of the yield stress are in fact the same. Therefore, along its length, the material investigated can be considered as homogeneous. The last section about the results is related with tensile test. This is section number 5.5. Let's look at this section. Figure 8 demonstrates the strain-stress curves obtained from the tensile test. Based on the figure 8, it can be concluded that both of samples taken from significantly different areas exhibited the same plasticity and similar strength. The two strain-stress diagrams are coincident and overlap each other partially. Moreover, the calculated values of mechanical parameters were similar. Therefore, it can be concluded that the material investigated was homogeneous along its length. Finally, I would like to go to the conclusions, which are placed in the section number 6. So, let's summarize this research and let's formulate the conclusions. In this work, a rod product 8 mm in diameter and about 700 mm long was manufactured. With such a relatively bulk and volumetric material, research was conducted on its structural homogeneity and mechanical properties. It was found that the material after recycling was characterized by the same homogeneous microstructure along its entire transverse section and its entire longitudinal section intended for observation. The microstructures along both the transverse and longitudinal section were the same, meaning that the material is three-dimensionally homogeneous. Despite the distance separating the top and end areas of investigation, the properties of both samples were the same or similar. Hence, along its length, the rod product exhibits homogeneous mechanical properties, as was confirmed by the hardness, compression test, and tensile test. Based on the indentation tracks and microhardness distribution, it was found that the titanium manufacture in this processing is isotropic. The results indicate that the rod manufactured was a good quality semi-finished product. Its microstructure and mechanical properties were homogeneous and analogous to those of commercial titanium available in the trade. This is all. Please note that these results will be also available in the conference proceedings. At the end, I would like to thank you for your attention. Goodbye.